Welcome back. This is All This Math. I'm Professor Parker. If you're here, hit the like button. If you're not subscribed already, hit the subscribe button. Also, if you have any questions or comments about anything that I'm about to explain, please put your questions or your comments in the comment section so I can find out. I might make a follow-up video based on your question. All right. Also, share this video with at least 2 people. And what are we doing in this video? We are doing addition of 2-digit numbers using the arrow way. This is something that your children might be introduced to in either first grade or second grade, depending upon what school they go to or what school district they're in, right? And what part of the country, right? But it's another good method to help develop fluency with numbers and, better understanding of the relationship between numbers and place value, especially. All right. So I got 2 examples up here. The first one is completely worked out. So I'm going to just explain what I did, and then we're going to do the second one together. All right. So the first one says 23 plus 14, right? Now, 23 plus 14 is equal to 37. All right. Now, using the arrow way, how did I come up with that answer? I start with the first addend. 23 is called an addend. Numbers that are being added together to find a sum. The sum is the answer when you do addition, are called addends. Addends. So I write down the first addend, which is 23. Then I'll draw an arrow, right? Then I go to the second addend and I break it down in terms of tens and ones, right? If it was a 3-digit number, we'd break it down in terms of hundreds, tens, and ones. So how many tens do I got? I got one group of 10. That's 10. So 23 plus 10 is going to take us to 33. Why though? Because 23 has 2 groups of 10 and 10 is one group of 10. So what happens when you put 2 groups of 10 with one group of 10? Altogether, how many 10s you got? You got 3 groups of 10. 3 groups of 10 is the same thing as 30 because that's 10 plus 10 plus 10. That's 30, or 10 times 3, which is 30, right? So that's where the 30 comes from, the 3 in the tens place. And then where does 3 come from? The 3 ones that were already there. The 3 ones that were already there. So that takes us to 33. Now, what do we got to do next? Draw another arrow and put a plus 4. Why? Because 14 is 10 plus 4, 10 plus 4, 10 plus 4. So I add 4 to 33. Now I can use the count on method, start at 33, go 34, 35, 36, 37. See, I got 4 fingers up, right? 4 fingers, right? So, and I stopped counting at 37. That's why my answer is 37. Or you could think of it like this. Separate this 33 into 30 plus 3, 30 plus 3. And then I want to add 3 plus 4. I could just add up all my ones, 3 plus 4. Now, hopefully, if your child is being expected to add 2-digit numbers, they already have some of their addition facts memorized. They already know that 3 plus 4 is 7 from memory, by heart. They should already know that, right? If they don't, please get them to the point where they just know 3 plus 4 is 7. And also they know 4 plus 3 is 7. That's called the commutative property of addition. When you switch the order of the numbers, the sum doesn't change. The commutative property also applies to multiplication. It doesn't apply to subtraction and division, though, but it does apply to addition and multiplication. We call it the commutative property, which means you can switch the order of the numbers around and you still get the same sum when you're doing addition. All right. So 3 plus 4 is 7. So that means that 30 plus 7 will give you 37. All right. Now, this next problem, we're going to work it out. If you want to, you can hit pause, try to work it out yourself. And then once you're done, then hit play and see what answer we got. All right. So I got 18 plus 17. So my first add-in is 18. So I'm going to start with 18. I'm going to write 18 down. I'm just going to write 18 down. And then I'm going to draw an arrow. And on top of my arrow, I'm going to put plus 10. Now, ask yourself, where does that 10 come from? It comes from the 17, because I'm basically breaking the 17 up or decomposing the 17 into 10 plus 7. I separate it into tens and ones based on place value, right? How many groups of 10 do I have in 17? One group of 10. How many ones do I have in 17? 7 ones. I got 7 ones and I got one group of 10. I'm going to add the tens first. See, it's the same process. Up here, I added the tens first, and then I added the ones. Add the tens on top of the arrow, add the ones on top of the arrow. All right, so I'm going to do plus 10 right here. And what does that give me? What's 18 plus 10? It's 28. Why? Because 18 is one group of 10 with 8 ones. So if I add another group of 10, now I got 2 groups of 10. So that means I got a 2 in my tens place, and I still got the 8 ones. So that's why this is equal to 28, right? Then I draw another arrow. What am I adding? I'm adding 7. Where'd that 7 come from? It came from the 17. The 17 is the same as 10 plus 7. 10 plus 7. 10 plus 7. That's 17. Now, what's 28 plus 7? All right. Now, this might get a little tricky. Now, a couple things we could do. We could count on, right, from 28. We could count on from 28, right? So we got your closed fist that represents 28. Put up 7 fingers. We're going to have to use 2 hands because each hand only got 5 fingers in it. So we count on from 28. So we go 29, 30, 31, 32, 33, 34, 35. That's 7 fingers, right? 7 fingers, right? 7 fingers, right? We added 7. We stopped at 35. Therefore, the sum is 35. That's the final answer. Final answer is going to be 35, right? Another way to do it is separate the 20 from the 8. Separate the 20 from the 8. Think about your addition facts. All right. Now, what's 8 plus 7? 8 plus 7, addition facts should be memorized, is 15. 8 plus 7 equals 15. So then we're thinking, okay, we're also doing 20. We could also look at it as 20 plus 15. What is 20 plus 15? 20. Now, this is where it gets a little, it's getting lengthy, but that's cool though. So 20 plus 15, we break 15 down into 10 plus 5. What's 20 plus 10? 20 plus 10 is 30, because now we got 3 groups of 10. 20 plus 10 is 30, and we got 5 left over. What's 30 plus 5? 35. It's another way to get 35. All right. Or you can think of it in terms of number bonds. Number bonds. All right. What if we took this 7 and broke the 7 down into 2 plus 5? Now, ask yourself, why would I do that? Always ask yourself why when you're learning different math processes and different math steps, right? Why would I break 7 down into 2 plus 5? How does that help me? I'm going to tell you how it helps you. Because if you break the 7 down into 2 plus 5, like as if it was a number bond, right? I know we're doing the arrow way, but we can still apply principles from other methods too. We could take the 2 and put it with the 28. What does that give us? 30. Gives us a number that ends in 0, which makes the addition easy. When you have a number that ends in 0, that makes the addition easy. So if I break this 7 down into 2 plus 5, we put the 2 with the 28, that gives us 30. And now what's left? That 5. So now we're doing 30 plus 5. So all those 3 ways will give us 35, right? And it's even more ways that I didn't even get into, right? So now we got 35. Boom, 35. That's our final answer. And that's the arrow way. So like I said, this is just another method to help your child become more and more fluent. Listen, the parents, if you're watching this, don't get frustrated. I'm trying to tell you, the more methods that your children know, the better they're going to be at math. So don't be that parent that just gets frustrated and says, well, why they can't just do it this way? Why they can't just do it this one way? No, that's not enough. Sure, the way that you learned it 30 years ago, the way I learned it 30 years ago, 40 years ago, is cool. It's great. But why limit them to just that method? The more methods your children know, the more fluent they're going to be with mathematics and number facts and number sense. The better off they're going to be, the more comfortable they're going to be, the better grades they're going to get, the more understanding of math and of the world they're going to have. Because when you really understand math, you understand the world better. Because mathematics is the language of the universe, whether you want to believe it or not. It is, right? It's the language of business, right? Finance, right? So, and it's the language of relationships, and how we quantify information and data and resources. So we want our children to learn as many methods as possible, because it's going to ultimately make them better math students and better mathematical minded people, which is what we want. We don't want kids that are scared of math. We don't want kids that are scared of math. And part of the reason that they end up scared of math is because somebody just tried to give them just one method of doing the problems and probably didn't even explain it that thoroughly, that one method. So they need as many methods as possible. So yes, teach them the arrow way, like we just did. Teach them number bonds. Teach them to make the quick 10 drawings. Teach them the standard algorithm, right? Teach them all the methods. And it's even more beyond that. Teach them as many as possible. So like I said, hit the like button. Subscribe if you didn't subscribe already. If you still got questions, that's cool. I want all the questions. Put them in the comment section. All right. And share this video with at least 2 other people. And do your research on Frederick Douglass. All right. Peace.